Okay, so we're going to talk about things we know about the Circumcenter. So the biggest thing that we know about the Circumcenter is what it's made from. And it's made from the perpendicular bisectors of each side of the triangle. Now, the next thing we need to talk about is what is a perpendicular bisector. So bisector means that it's cut into two equal parts. And if it's cut into two equal parts, that means that it goes through the midpoint. And the way that we can find a midpoint is with our midpoint formula. The average x value and the average y value. And the next part is the perpendicular. So it goes through the midpoint and is perpendicular to the side of the triangle. And the thing that we need to keep in mind is that perpendicular just means that it has the opposite reciprocal slopes. And that's the biggest thing that we know about the Circumcenter. And that information does us a lot of good, especially on a graph. But something else that we know about the Circumcenter is that it is equidistant from all the vertices of the triangle. And that's because it's the center of the circle outside the triangle. So what that looks like is that if you have some triangle, you're most interested in the circle that goes around it. So here would be our circle. And if we put a triangle in this, the center of this circle is the Circumcenter. So with that being said, the segments that go from the Circumcenter to the vertices are all radii, and all radii are exactly the same length. So that's where we get equidistant from the vertices. The vertices are just the points on the triangle. Okay, so let's say we need to solve for some missing parts using our Circumcenter. So all of the given information is already in our picture here, and we're looking for the value of A. And if we notice, it says that C is our Circumcenter. So this point down here, C, is the Circumcenter. And things that we know about the Circumcenter are that it's formed by perpendicular bisectors. So that means that the points Y, W, and X are all the midpoints. So we know that each of these sides of our triangle, LN, LM, and MN, are all bisected. So they are going to be congruent parts. So if the whole segment of MN is 26, knowing that Y is the midpoint means that each of these is 13. And to get that, we took 26 and we divided it by 2. So if we look at the first question, 13 may be helpful to us in a minute, but the first question says, what's the value of A? So we're going to find the segments that involve the value A. And we have one right here, 2A plus 4. We have another one, 3A minus 1. Now in this picture, they went ahead and gave you some important information, and that is that those segments are congruent. They didn't have to tell you that, because if C is the Circumcenter, we know that it's equidistant to the vertices, and M and N are both vertices. So if the segments are congruent, we know that their values are equal, or their measures are equal. So 2a plus 4 is the same as 3a minus 1. So if we solve this for a, we find that 3a is equal to 2a plus 5. And if we subtract 2a on both sides, we have our a value now. We have a equals 5. So we've completed the first task at hand. We have a equals 5. Now looking at the second one, it says that we need to find yc. So we identify yc. Here it is. Now as of right now, it doesn't look like we have a lot to go on. But yc forms this right angle when it's combined with, say, yn. And if we use yc, yn, and cn, we form a right triangle. This is the side that we're looking for. We're looking for yc. This side doesn't have a measure on it, cn, but we did in the last problem solve for a. So if we plug a in, we get that cn is 14. So now we have two sides of our triangle. We have 13. We have yc over here. And we have 14 on segment CN. And when we have two sides in a right triangle and we're looking for the third side, we could call it B, we're going to use the Pythagorean theorem. So we're going to apply a squared plus b squared equals c squared. Now the important thing is knowing that c squared, c is always the hypotenuse. And we always find the hypotenuse by looking directly across from the right angle. So looking directly across from the right angle is going to give us 14. That side has to be c. So we can put in 14 squared. And the other two sides, we can just fill them in. So 13 squared plus b squared. And so now we can work this thing out and get 169 plus b squared is equal to 196. And we can do some subtraction here. And we'll have b squared is equal to 27. And now to finish the problem, we're going to take the square root of each side. And when we do that, we need to think about breaking down this 27. So 27, we can break it down into square root of 3 times the square root of 9. And the square root of 9 is a perfect square. It's going to just give us a 3. So our answer for B will be 3 square root of 3. And if we remember, B is what we set equal to YC. So now we have found that YC is equal to 3 times the square root of 3. So the last kind of problem that we can do here is finding the circumcenter of a triangle when it's in a coordinate plane. So we need to find the circumcenter of triangle PQR, and I've given you the coordinates for P, Q, and R. So we're going to go to point P here at -4, 0. So 1, 2, 3, 4, 0. That's our first point, and we'll just call it P. Our second point of Q is at 0, -1, 2, 3, 4, 5, 6, 7, 8. Here's point Q. And our last point, R, is at the point 4, 4. And we need to connect those so that we can finish our triangle. So again, we find ourselves wondering, what is the circumcenter made from? And the circumcenter is made from the perpendicular bisectors. We said that bisector is very important because it means that you need a midpoint. And our midpoint formula, once again, was the average x value followed by the average y value. So the first thing that we're going to do is find the midpoint of one of our sides. So we choose a side, and the side that we can choose first is, let's say that we chose PR. That means that our midpoint is going to be, our coordinates for P were -4, 0, and our coordinates for R were 4, 4. So our average x value will be -4 plus 4 divided by 2, and our average y value will be 0 plus 4 divided by 2. And so our midpoint will be 0, 2. So we find the point 0, 2, and we plot it. And we can call this point M if we so choose. Now, the next thing that we have to consider is this perpendicular. And so for perpendicular, we're going to find the slope of the line that we're on. So we're going to find the slope of PR. So we go ahead and do that. So we say we're going to use y2 minus y1 over x2 minus x1. So we can say that we're going to do 4 minus negative, we can do 4 minus 0 over 4 minus -4. And that's going to give us 4 over positive 8, which is positive 1 over 2. That's the slope of the line PR. But we want the perpendicular slope. So the line that's perpendicular to PR is going to have a slope of the opposite reciprocal of 1/2, which means that we're going to change the sign and reciprocate the fraction. So we're going to go to our midpoint of M, and we're going to use the slope of -2 over 1. So that means that we have a rise of -2 and a run of 1. And we can continue that process as far as we need to. And we will use a green segment since we've been using green already. And we fill that in, and we can see that we've made a right angle here. So we know that these are perpendicular lines. But one isn't enough for us to finish. We need to have at least 2 of our perpendicular bisectors. So we're going to repeat the process choosing another side of the triangle. So we're going to repeat with another side. And let's say that we repeat with the side PQ. You don't have to use PQ, but we're going to. So we're going to repeat this whole process. So the first step was finding the midpoint. So the midpoint of PQ will be our average x value followed by our average y value. So we're going to say -4 plus 0 over 2, comma, 0 plus -8 over 2. So our midpoint of PQ will be -2, comma, -4. So we go to -2, -4, we plot our point, and we'll call this one N so we have a different letter to work with. The second thing that we need is we still need to find a perpendicular slope. So we start by looking for the slope of PQ. And we're going to use our same slope formula that we used before. But for this one, we can say that we're going to do -8 minus 0 over 0 minus -4. And we see that we get -8 over positive 4, which reduces to -2 over 1. We're not concerned with that slope, though. We'd like the perpendicular slope. So the perpendicular slope for PQ would be positive 1 over 2. Which means that from our point N, we're going to use a slope of positive 1 over 2 until we can see where these two are going to intersect. You could keep going, but we can see that there's an intersection point already. So again, we'll color coordinate. And we can see that these two lines, these two perpendicular bisectors, have intersected at this point on our graph. That point then is your circumcenter. And we can then label it as 2, negative 2, because we are at the point 2, negative 2.